Welcome you all to the week 11 problem solving session of differential equation for engineers. Myself Guru Bachan from Department of Mathematics, IIT Jodhpur. In today's session, we mainly focus on solving the heat equation. While in the last session, we focus on the solving initial boundary value problem of wave equation with the help of method of separation variable. In this lecture also, we follow the similar kind of approach. That means the same method of separation of variable to solve initial boundary value problem of this heat equation for case of finite rods, you can say. So let me start with the question number 1. Solve the initial boundary value problem to heat distribution in a finite path with insulated ends given by ut minus c square uxx equal to 0, where this x lies between 0 to L, t is any positive number, initial condition is given as e to the power minus x for any x between 0 to L, and ux 0t is 0 and ux lt is also 0 for all t greater than equal to 0. So insulated means basically you can say if you have some kind of rod or bar. So insulated means these both ends, at these both ends velocity of heat flow is 0. So here it is ux 0t which is 0. Here ux lt is also 0. We have given this thing. So we have to solve this equation, or you can solve this initial boundary value problem for this heat equation specifically. So what you will do, likewise the earlier class or earlier problem solving session, that is of week 10, what we have done, we have assumed that uxt is some x of x, any non-trivial solution. That means neither x of x is equal to 0 for all x, nor t of t is equal to 0 for all t. So we are trying to follow the method of separation variable approach. So in this case, what will be your ut xt? It will be x of x t dash of t, ux of xt x dash of x t of t, uxx of xt x double dash of x t of t. So from the given heat equation, ut minus c square uxx equal to 0, this will give us that x of x t dash of t minus c square x double dash of x t of t is 0. Now from this, what we can write, x double dash of x divided by x of x is same as t dash of t c square t of t equal to some lambda, say, and lambda is here constant. So we are trying to convert this system into again the Sturm-Liouville system, so that we can find out some eigenvalue and corresponding eigenfunction, and with the help of those eigenvalue and eigenfunction we can follow up to get the original solution. So what we do? So we have given the boundary condition ux0t is 0 and uxlt is 0. What is ux0t means? From here you can observe ux0t is 0, meaning x dash of 0 t of t is 0. So as I told you, t of t cannot be 0. So x dash of 0 will be 0 because t of t cannot be 0 for all t. In the same way, ux of lt 0, this will give us x dash of l t of t is 0. Then this will give us x dash of l is 0. So from here, what Sturm-Liouville problem has been formed is like this: lambda x of x is 0 and the given condition is x dash 0 is 0, x dash of l is 0. So this is the Sturm-Liouville system. Corresponding to this system, we want to find out its eigenvalue or corresponding eigenfunction. So since we have done in the last class these kind of problems, you first try at your own, then we will discuss it. So again we have to divide the cases. We know that lambda is a real number. Lambda can be only the real number. So we have to divide the possibilities. If lambda is greater than 0, that means we have to assume it should be some mu square and mu is positive. So in that case, what will be our auxiliary equation? It will be m square minus mu square equal to 0. This will give us m can be either plus mu or minus mu. So from here you get your x of x will be c1 mu x plus c2 minus mu x. So x dash of 0 is 0. This will imply C1 mu e to the power 0 is 1. Then C2 mu is 0. We know that mu is positive. That means C1 is C2 because mu is only positive number. Next is x dash of L is 0. This will imply C1 mu e to the power mu L, and we know that from this equation C1 is equal to C2, so we may write this as minus mu L equal to 0, and from here C1 mu e to the power mu L minus mu L is 0, and this quantity is non-zero quantity for every L or mu. So this will imply that C1 has to be 0, and if C1 is 0, then C2 also has to be 0. That means x of x is 0 for all x. So that implies that lambda greater than 0 is not an eigenvalue of the Sturm-Liouville system. Okay. Next case will be lambda equal to 0. That means auxiliary equation will become m square minus 0 is 0. That means m can be 0 and 0, and x of x can be c1x plus c2. X dash 0 is equal to 0. This implies that c1 can only be 0. X dash of L is 0, which will give us natural equation 0 equal to 0. That means we left with x of x equal to C2, which is an arbitrary constant. So we got some non-zero solution. If we assume that if C2 is some 1, for non-trivial solution we get x of x as 1. So therefore lambda equal to 0 is an eigen value of the SL system, and the corresponding eigen function is x of x equal to 1. Next case is lambda less than 0. So that means lambda can be minus mu square and mu is strictly positive. Then auxiliary equation will be mu square m square plus mu square equal to 0, and this will imply m can be plus minus iota mu. So then x of x will be c1 cos mu x plus c2 sin mu x. So from here we know that x dash 0 is 0. When we do the derivative, cos will become sin and sin 0 is 0. So we left with c2 mu cos mu x, that is cos 0 will be 1. This will be 0, and this will imply c2 has to be 0. Next is x dash l is 0. So since c2 is 0, we left with c1. That means minus c1 mu sin mu l. This has to be 0. If since we want mu is positive, so if c1 is non-zero, only in that case we can find out the non-trivial solution. So if c1 is non-zero, then sin mu l has to be 0, and from here mu l has to be some n pi, and mu has to be n pi by l for any natural number. Since mu is positive, so we have to take only the natural number possibility. So that means this will imply lambda less than 0, or you can say, what is exactly lambda? This is minus n pi by l square, where n is any natural number, r eigen values of the SL system. Since it's depending on n, so we can subscript here n. SL system and the corresponding eigen functions are x and x equal to c1 cos mu x, and mu is n pi by l, so n pi x by l, where n is any natural number. Okay, so from here you got your eigenvalue, or you can say if we combine both the cases, so we may write lambda equal to minus n pi by l square, where n can be any whole number, while x and x can be written as some c1 cos n pi x by l for any n whole number. Okay, because if you will put n equal to 0, so lambda n becomes 0, and x and x will give you c1. That means again the some constant, so we may even remove here c1. We may consider only this particular c1 as 1. So from here what you will get, you got x and x. Now what you can do, and you also got your eigenvalue. So t dash t, you know that it is minus lambda c square t of t is 0. We know this thing, and we found out the value of lambda. It is minus n pi by l square, so that means n pi this whole square equal to 0, and since it was minus, so this will become plus. So from here you will get your t of t as, in fact it is depending on n, so t n of t. It's a simple linear first order ODE, so you can directly solve by separation of variables. So it will give you some an e to the power minus n pi c by l whole square t. So if you will write any u n x t, this is x n of x, t n of t. This will give you a n minus n pi c by l whole square t sine, cos n pi x by l. Here we have not considered that c1 constant. If we consider c1 constant, then the c1 and this an will combine and become a different arbitrary constant that we have to find out later on. So by superposition principle, this is the solution with respect to some n. So by superposition principle, uxt will be n 0 to infinity unxt. Since n can be any whole number, so that is why here n 0 to infinity. So this will give you n 0 to infinity an e to the power minus n pi c by l whole square t cos n pi x by l. Okay, next we have to find out this an constant. So we will use the given condition that ux0 is e to the power minus x. So that means summation n0 to infinity an cos n pi x by l is e to the power minus x. Now we will use orthogonal property of this cos functions. What are orthogonal property? 0 to l cos n pi x by l cos m pi x by l. So dx is equal to, there will be three cases: L if m equal to n equal to 0. If both are 0, then obviously you will integrate a function 1, and integration of 1 is x. From 0 to L, it will be L. It will be L by 2 if m equal to n but not equal to 0. That means m and n are equal, and then you will get here cos square n pi x by L. Then by half angle formula, you can convert into cos 2n pi x by L. If it will be 0 if m is not equal to n. Rest of the any possibility where m is not equal to n, then this integral will going to be 0. So by this property, what we can say, we may multiply with the cos n pi x by L to this equation number 1, and we try to find out a n corresponding to that. We know that m is equal to n and not equal to 0. First of all, we consider that case. Let m equal to n is not equal to 0. So in this scenario, this integral a n 0 to L. So if you will write this integral, so what you are doing, you will first multiply cos m pi x by L equal to e to the power minus cos m pi x by L. And what we want to do, we want to integrate this one 0 to L. Okay, so this integral only makes sense if m is equal to n, and I am assuming m is equal to n but not equal to 0. So that means this an and a naught will be definitely going to 0, and rest of the integral will give you L by 2, and from here you have to calculate this 0 to L e to the power minus x cos m pi x by L. That we need to calculate some explicitly manner. Since m equal to n, so here I can write cos n pi x by L. So how we can calculate this? Suppose I is n integral e to the power ax cos bx dx. So this will give you e to the power ax cos bx divided by a. I am applying this Eilert preference of, you can say, differentiation or integration. Trigonometric becomes first, so that means that will be preferable for differentiation, and exponential will be preferable for integration. So minus integration e to the power ax by a, and this will give you sine bx into some b dx plus sign. So again, if you will integrate, but you will get some kind of repeated terms you will get. So from here it will be again e to the power ax b sine bx divided by a square with negative sign e to the power ax by a square, and this will be b square cos of bx dx. So this will give you a cos bx plus b sin bx, and outside this e to the power ax you can take common and divide by a square. Okay, and this will give you minus b square by a square, and the left term is nothing but the integral I. So if you will take this integral I to the right hand side and solve it, then you will get here a square and a square will cancel out. So you will get here e to the power ax divided by a square plus b square a cos bx plus b sin bx. Okay, so just a second. I hope it will disturb, not disturb now. So this is your integral plus some arbitrary constant. So we have find out this indefinite integral, but here it is some 0 to L. So we just need to substitute the value, and here the value of a is -1 and value of b is n pi by L. So use this one, and an is equal to, you can say, 2 by L. 1 by value of a was -1 and b was n pi by L square, and from here e to the power x is outside, so e to the power minus x. Inside it will be minus cos n pi x by L plus n pi by L sin n pi x by L. So this will 0 to L. So from here you will get 2L divided by 1 plus n square pi square. So from while putting L, so you will get e to the power minus L. This cos will give you cos L and cos n pi, that will be -1 to the power n with negative sign, then minus, and sin L n pi is 0, so we will ignore it, and while putting n equal to 0, this will give you minus e to the power 0, that is 1, and again sin 0 is 0. So from here you will get 2L divided by 1 plus n square pi square and 1 um, minus 1 to the power n e to the power minus n. So let me just cross verify this an. So here we just miss a typo, so it will be L square after taking LCM, and rest of the thing is correct. So if you will observe from here, when your n is an even number, so that means this give you positive value. So can it be some sense of can it be 0? No. So this cannot be 0. Earlier in the previous sessions, so this quantity will become 0 because here e to the power minus L will not play the role. So here, and also observe here n can be only natural number. The reason is earlier n was a whole number, but we have considered the case m equal to n but not equal to 0. So that case we have to solve explicitly. So what we do, we solve the series for m equal to n equal to 0 case. Okay, so that means what we do, uh, n 0 to infinity, it was an cos n pi x by L. This was equal to e to the power minus x. So what we do, we multiply with 1 dx and integrate it, 1 dx 0 to L, so that this integral exists only m equal to n equal to 0. So that means, so this will give you an into L, which will be equal to, so this integral exists only when n is 0. That means a naught into L, and this will be minus e to the power minus x 0 to L. So this will be 1 minus e to the power minus L divided by L. So from here you got the value of a naught. So after this we know that value of a naught, we know the value of en, we can conclude our uxt. So our uxt is 1 minus e to the power minus L divided by L plus the series n 1 to infinity 2L divided by L square n square pi square e to the power, oh, this will be left only, so 1 minus 1 to the power n e to the power minus L. So this is your constant. So next is minus n pi c by L whole square t cos n pi x by L. where this x can be any number between 0 to L, t is greater than 0, is the required solution of the given initial boundary value problem. So this is your required solution for the given initial boundary value problem. So in the same scenario, let me give you one more question, but with different boundary condition or different framework, on a different framework. So this is like this. So question number 2, find the temperature in laterally. I will mention further what is laterally insulated copper bar of 80 centimeter long if the initial temperature is 100 sine pi x by 80 degree Celsius, and the ends are kept at 0 degree Celsius. So how long it, or you can say how long will it take to for the maximum temperature in the bar to drop to 50 degree Celsius, and given that diffusive constant for copper is 1.15. So let us start. First of all, what is this laterally insulated copper bar? So we have given a copper bar. So suppose this is some kind of copper bar. So I am saying laterally insulated means this direction and in this direction there is no heat of exchange. So this rod is not exchanging the heat from this vertically direction. Okay, next is we have given that it is 80 centimeter long. So in general we know that ut minus alpha square uxx is 0 for any 0 to x to L, and t is some positive number. We have given a condition fx where x can be any 0 to L, and u 0t or anything we have given. So here if you will observe that you have given u0t as 0 ult for any t greater than equal to 0. So diffusive alpha is a diffusive constant, so alpha square will be here 1.15. this whole alpha square is known as diffusive constant. Next is what is L? L is 80 centimeter we have given. Next they have told that the ends are kept at 0 degree Celsius. So that means this first and this last end is having a 0 degree Celsius temperature. That means U0T is 0 as well as ULT is also 0. So now you form the equation, heat equation, and Ux0 is given as some Fx, which is 100 sine pi x by 80. So we know all the quantities. First of all, we have to solve this equation by again with the variable separable or method of separation of variable. So what we will assume, we assume that our u x t is nothing but x of x, t of t is non-zero. Now from the previous question, what we can say, x double dash of x divided by x of x, this is same as t dash of t divided by 1.15. Here alpha square is 1.15. T of t equal to lambda c. Okay. So from here your Sturm-Liouville system will become lambda x of x is 0, and we have given u0t is 0 and ult is 0. So u0t is 0. This will imply x of 0, t of t is 0. That means x of 0 is 0. Similarly, because t of t cannot be 0 for all t, since we are trying to find out a non-trivial solution, x of L is 0. So this is your Sturm-Liouville system for which you have to divide the cases. So first of all, you can try it here in the same way that we have done the previous question, then we will discuss it. Let us start discussing its cases. First case is lambda is greater than 0. So this can be divided as lambda equal to mu square and mu is any positive. So from here your auxiliary equation will become, okay, so from this you will get x of x as c1 e to the power mu x, c2 to the power minus mu x. So x0 is 0 will imply c1 plus c2 is 0 and c1 is minus of c2, or you can say c2 is minus of c1. That will be more convenient. So x of L is 0, so that means c1 e to the power mu L, c2 is minus c1 e to the power minus mu L is 0. So this will imply c1 is 0 because e to the power mu L cannot be equal to e to the power minus mu L for all mu greater than 0, or you can say for any mu rather than for all. You can say here for any mu greater than 0. So from here, if c1 is 0, that means c2 has to be 0. That means x of x is 0 for all x. Therefore, lambda equal to mu square is not an eigenvalue for the SL system. Lambda equal to 0, m square equal to 0, that implies m is 0 comma 0. So from here x of x will become c1 plus c2x. So we have given that x of 0 is 0, so this will imply c1 is 0. Next is x of L is 0. Since c1 is 0, now we have left with c2 L is 0. Since L cannot be 0, that means c2 has to be 0. Again you will get x of x is 0 for all x, or you can specify it for all x between 0 to L. Here also you may specify it for all x between 0 to L. So therefore lambda equal to 0 is also not an eigen value of the SL system. Lambda less than 0 is the case only left. So in this scenario, lambda can be minus mu square and mu can be any positive number. So from here your auxiliary equation will become, this will imply m equal to plus minus iota mu. So from this you will get x of x as c1 cos mu x plus c2 sin mu x. So since x of 0 is 0, this will imply c1 is 0. Next is x of L is 0. This will imply c2 sin mu of L is 0. Since we are targeting some non-trivial kind of solution, so we may assume that c2 is some non-zero, then sin mu L is 0. So from here you will get mu L as n pi. Since we are we are seeking to find out positive mu, so it will be n can be only natural number. So n pi by L, where n is any natural number. So from here you can say lambda n equal to n pi by L square with negative sign for any n natural number is, or you can say r, as r is varying, or n is varying, so r eigenvalues of the SL system, and x and x will be equal to C2, since C2 is non-zero, sine n pi x by L, and this C2 will depend on n also. So what we can do, we may write some C2n kind of thing. Okay, are corresponding eigen functions. So only the lambda negative case give you some eigenvalues and eigenfunctions. Corresponding to these eigenvalues and eigenfunction, what we are targeting to find out u and xt. Before that, you have to find out t dash of t. So what will be that? T dash of t is minus lambda. Here lambda is minus n pi by L square into some c. Here alpha square is, we have given that 1.15. So we may write it, and here also we have also given that L as 80. So we may write L as 80, but after that completion of this, you can say u and xt, we may write it. So square t of t, this will help in further questions also, is 0. So from here you will get Tn of t is equal to some constant an e to the power minus n pi alpha by L square t. So combining, or you can say multiplying this, you will get u and xt as an into c to the power n, which I am writing capital An, e to the power minus n pi alpha L square t sine n pi x by L, where n is natural number and capital An is any C2 depending on small a, their multiplication. So by again superposition principle, what we have, uxt is summation of all these natural number u and xt, because lambda eigenvalues are existing for any natural number. So uxt will give us summation n 1 to infinity capital An e to the power minus n pi L alpha L square t sine n pi x by L. Now you may substitute alpha square as 1.15, L as 80. So this will give you uxt as summation n1 to infinity an e to the power minus n square pi square, or you may write constant first. So that means 1.15 n square pi square divided by 80 t sine n pi x by 80. Now we have to find out this arbitrary constant an. So we have given a condition that fx is 100 pi x by 80. That means ux0 you have given the initial condition. ux0 is 100 sine pi x by 80. So that means this series n1 to infinity an sine n pi x by 80 is 100 sine pi x by 80. So similar to the earlier cases or the previous class also, so we may find out here what is the value of an with the help of orthogonal property of this sine function. So you can try at this stage at your own, then can finalize we may what is this uxt exactly. Try this one, then we will discuss it. So as I told you, here we again use the orthogonal property of this sine function. So what is that? We will multiply sine m pi x by l on both sides and we integrate from 0 to l. So this series n sine n pi x by 80. So here it would be 80 because we have given l is equal to 80. Sine m pi x by 80 dx 100 0 to 80 sine pi x by 80 sine m pi x by 80 dx. So let me recall 0 to L sine n pi x by L sine m pi x by L dx. This gives value L by 2 and 0 if m equal to n, if m not equal to n. So the left hand side integral only makes sense when m equal to n. So this integral is a n n 80 by 2 when m is equal to n. So m equal to n. Okay, so you left with this, calculate this right hand side integral. So this is sine pi x by 80 into sine n. Since m equal to n, so we may replace m with n. So now if you will observe, here is also, here the value of this n is 1, here it is n. So these two, this integral also makes sense only when n equal to 1, otherwise this integral will be 0 by the orthogonal property of this sine function. So from here your 40 an is, if n equal to 1, then only this will give you value L by 2, that is 80 by 2. Otherwise this will give you value 0 if n not equal to 1. So that means an is 100 if 40 will cancel out if n equal to 1, and this is 0 if n not equal to 1. So this is your an for all natural number. Okay, so what is uxt from here? This was a series, but since n not equal to 1, or you can say from here, let me just rewrite in this way, that a1 is 100 and an is 0 for all n greater than equal to 2. So that means your uxt will contain only one term, and that term is uxt equal to, it was a series earlier, an e to the power this series, so we will left with e to the power minus 1.15. Since the value of n only it is valid, so this will be 1 square pi square divided by 80 square t sine pi x by 80, and the value of a1 is 100, so this will be uxt equal to 100. So you may approximate this above exponent, so this will be somewhatly likely to 100 sine pi x by 80 e to the power minus 0.00177 t. This is your uxt. So this is the first part of this question. Now what will be the second part they have asked for? They have asked that how long it will take for maximum temperature to drop to 50 degrees Celsius. So that means we have to first find out when this temperature will be maximum. So at the maximum stage, if you will observe that in this uxt, this e to the power 0.00177t only depends on t. Since this is the case, so if this is only depending on t, what we can say? Therefore, the place where umax occur, that will depend only on the term that contains x. So umax occur only when sine pi x by 80 is 1. So sine pi x by 80 is 1, that means pi x by 80 has to be some pi by 2, that means x has to be 40 centimeter. So that means the whole rod has length 80 centimeter. At the half of the rod you are getting your maximum temperature. Now you got what is the maximum temperature here. The next target is when this temperature drop to this 50 degree Celsius. So with respect to this umax, what I may write here x max. Okay, so we are finding that value of x for which this integral give you maximum value. Okay, so our target is when this u max will become 50. So from the given 50 can be any 100, and what is sine pi x max is 40 divided by 80, that is 1. So you are talking about u max, so this will be having at sine pi by 2, this will 1, so we don't need to write that expression, and we left with e to the power minus 0.00177 t. We have to find this time t, how long it take we are discussing, so we need to find out t. So from here, if you will observe that, you will get 0.00177t is equal to 2. So if you will take logarithmic on both sides, so ln2, you will get this exponent outside ln e, ln2, because ln x to the power n is ln x. Okay, so from here you will get your ln e is 1, you will get your t is ln 2 divided by 0.00177. So if you will approximate this t, so numerically it will come out to be some 391 seconds. So we are aiming, or we are seeking for this time, how long it will take to reach this maximum temperature to drop to 50 degrees Celsius. So next question we discuss, it contains, you can say, some, we have given some rod and we have given some temperature u1 and u2 at both the end, and we want to find out the temperature, you can say how temperature at a long time, you can say at t tends to infinity, what will be your temperature. So let me write it formally. Suppose that, suppose a thin bar has temperature u1 at x equal to 0 and u2 at x equal to L. Initially find the temperature in bar after a long time. So we have given, they are talking about some kind of heat transfer. So if you will write it, ut minus alpha square uxx is 0, and your length of this bar is 0 L, oh, that is L, sorry. So we have also given that u0t is some u1, where t can be any positive real number, and ult is given as u2 for any greater than equal to 0. So we have not given here the initial condition, you can say. So this is a kind of boundary value problem. So The best way, or you can say smarter way, is to think like that. This is method 1. We want to discuss after a long time what will be going to be the temperature, or you can say um, our main target is what will be its temperature after a long time. So for that, what we will do, so after a long time, the bar reaches thermal equilibrium. Thermal equilibrium means it will be not affecting by the ut derivative. So that means del u by del t is 0. So this will imply we will left with my the in the heat equation is 0. So if this is 1, so you can say 1 implies this one, and this will imply uxx is 0. From here auxiliary equation will be m square equal to 0, m is 0 0. So you are only depending on x, if typically I would say. So you can say ux will be some c1 plus c2 x. Next is, it has been given u0 is u1, so this will imply c1 is u1. ul is u2, so this will imply c1, that is now u1 plus c2 l is u2. So this will give you u2 minus u1 divided by l. Okay. So from here, if you will conclude, ux will be u2 minus u1 l x plus 1. Okay. So if you will write in the form of question, given question, so this will be uxt when t tends to infinity. This will be nothing but u2 minus u1 divided by l x times of u1. This is your one approach. The another approach that has been even told in the week 11 lectures is as follows. What you will do, you will assume one initial conditions given. So suppose ux 0 is some fx, and then you will also let to know why I am ignoring that you can say t terms, or after a long time I am saying it is only depending on, it will depend on temperature, depend on x. You will get here u0t is given as u1 and ult is given as u2 for all t greater than equal to 0. So by again method of separation of variable, you will assume uxt to be any non-trivial solution, that is x of x, t of t which is non-zero. So this will give us again with the same kind of, you can say, equation. So that will be x double dash of x divided by x of x, t dash of t divided by alpha square t of t is equal to some lambda say. So if you will observe here, x double dash of x minus lambda x of x is lambda, oh sorry, is 0. And also we have given that x0 is some u1, x l is u2. Can we say that? Obviously we cannot say that. The reason is, if you will put x0 t of t, that is u1. Earlier it was u1 is 0, so you can say that x0 is 0. but in this case it is not like that, so you cannot do in this manner. So in the class it has been told that you have to change the system in such a way so that it will this boundary conditions will become zero. So what you will do, you will smartly construct a new system uxt, which is vxt, which is uxt plus some gx function. Why I'm saying only gx? Because only at x they are depending on u1 and u2, so this will only contribute rather than t. So from here what you will assume, you want to target that your u0 v0t has to be 0, and you want to target that vt minus alpha square vxx, it should be 0. Also we want use v0t to be 0 vlt, and while vx0 is obviously it should be some fx. We want this kind of system or this kind of initial boundary value problem so that we can discuss its solution. So for this, if you will observe that from if v has to be satisfy the equation, that means what is vt? Vt will be ut plus 0, while minus alpha square vxx will be uxx plus g double dash of x. This has to be 0. So this will imply ut, or you may write g double dash x is equal to ut minus alpha square uxx. And if you know that u is a solution, then this has to be 0. If this has to be 0, then g double dash x will be 0. That means gx will be some c1x plus c2. Now we are targeting that this v0t is 0. So to make v0t is 0, if you will put the value v0t is equal to u0t plus g of 0, so this will imply g of 0 is minus u1, and v of lt is u of lt. So if you will somewhat switch here, switch in the way, you have to find out uxt plus some gx rather than vxt plus some gx. Here it should be uxt is equal to vxt plus some gx, because uxt is a complete solution rather than vxt. Also you can go with this manner, but for simplicity I am doing this following way. So from this, your u0t is v0t plus g of 0. So from here this will be g0 will be 1. Next is this is g of l, so this will give us g of l as u2. So if you will try to apply this one, so this will give you c2 is u1, and this will imply c1l plus u1 is equal to 0. Oh sorry, u2. So c1 will be u2 minus u1 divided by l. So from here you got what can be the restriction on this gx and what can be your uxt. So if you will see the system, or so what will be that? This will be vt minus k times of vxx, it will be 0, and your vx0 is you can say fx, and your v0t is 0 since g0 is u1, and vlt is also 0. Okay, So again, this t is greater than 0. So t is greater than 0. So this solution of this system initial boundary value problem you already know, that we have done in the previous question number 2. So what is that? I am writing directly here. So from question number 2 we know that, so it was alpha square, I mean, so here it is not k, here it is alpha square. So from here you may write vxt is series of sine function an, so just let me, e to the power minus n pi alpha divided by l square t sine n pi x by l. Okay, and an can be find out in the way 2 by l, 0 to l sine n pi x by l f of x dx. So you know the value of vxt. So now what will be the value of uxt? So uxt will be summation this an, and an can be find out with the above given expression, sine n pi x by l plus u2 minus u1 divided by l plus u1. Okay, so what we have to find out, this limit t tending to infinity after long time. So this series will contributing 0, and we will, and this is independent of t, so we will left with this expression which is the same as we got from method 1. Okay, I hope it is clear here. So next is, in the next question we are targeting to get the temperature of this rod. We have given that this lateral surface is insulated. Insulated means again the velocity of the at two ends is 0. So for that, let me write it formally. Question number 4. Find the temperature in a bar of length 2 whose ends are kept at 0 and lateral surface insulated. So sorry, here lateral surface insulated we have mentioned, that is in vertical direction there is no heat transfer. So when the initial temperature is sine pi x by 2 plus 3 sine 5 pi x by 2, and diffusion constant for, or you can say diffusion constant given is c square here. So this is a simple problem. You have to just construct its heat equation, then you get directly your answer with some little manipulation. So try at your own, then we will discuss. So here I would like to first mention one thing, that in the previous question we have here use v0t to be 0. We are targeting that thing. If we choose v0t to be 0 equal to vlt, so we are just if we choose a v such that these conditions are holding, so only in that case we got this gx, and with the help of this gx you may judge that this will not be fx, this will be some f1x. Why I'm saying that? Because you got that from here. So let me just mention it. So from here you got that uxt is vxt plus u2 minus u1 divided by l x plus u1, and you have given ux0 is some fx, which is implies vx0 is equal to fx minus u2 minus u1 l x minus of u1. So I am calling it as a new f1x. So this an will also be defined with respect to f1x, and then the thing will remain same. So that was just a little typo, or you can say a little ambiguity that I have been resolved. Now you may try this fourth question. So let us start discussing this one. So if you will observe here, you have given a bar of length 2. That means the value of L is 2 and your diffusion constant is c square, that is alpha square is nothing but c square. And we have told that both the ends are kept at 0. So that means u0t is 0 equal to u2t. And since we have given that this is laterally insulated, so that means there is no heat transfer in this vertical direction. Okay, so if you will write it appropriately, so this equation will look like heat equation with this, where your x lies between 0 to 2 and your ux0 is given as sine, initial temperature it is given as sine, that means here we have given a temperature, oh sorry, that means here is the temperature flow. So at this position, at 0 you can say, at this stage, sine pi xt 3 sine 5 pi x t, 0 to x lies between 2 and u0t is 0 to p, where t is any real positive real number. So this kind of system or heat equation we have solved in question number 2. So this gives us value that uxt must be this kind of series an e to the power, it was minus n pi alpha by L. So here alpha is c minus n pi c, L is 2 square t sine n pi x by L, that means n pi x by L is 2. Okay, next is an can be find out from 0 to L, that is 0 to 2, sine n pi x by 2 fx dx, where fx was ux0. So this will be 0 to 2 sine n pi x by 2 sine pi x by 2 dx. One integral is this, or I may divide in the second step. So plus sine 5 pi x by 2 dx. So now you may divide this integral into two parts, and this will give you 0 to 2 sine pi x by 2 pi x by 2 dx plus 0 to 2 sine, so here it was 2 by L also. So since the value of 2 by L is 2, so this will contribute only nothing, you can say, in the expression. So n pi x by 2 sine 5 pi x by 2 dx. So from here, if you will recall the orthogonal property of this sine function, that this integral makes sense only when m equal to n. यहाँ पे here the value of m is 1 and here the value of m is 5. So that means when n equal to 1, then this integral will contribute as L by 2, that is 2 by 2. While the value of n is 5, then this integral again contribute as 2 by 2. Otherwise, this these both integral will become 0. Here let me write as 0 plus 2 by 2, 0 plus 0. This is the orthogonal property of this sine function that I have mentioned in the previous questions also. So if you will write In another way, a1 is 0, a5, a1 and a5 are 1, and an is 0 for all n in natural number except this 1 and 5. So that means your uxt can be written for only these two terms. That is, so the correct way to write it, sine pi x by 2 e to the power minus pi c by 2 whole square. Since n is 1 in the first term, in the second term n will be 5, so it will be sine 5 pi x by 2 e to the power minus 5 pi c by 2 whole square t. So this will be your, just a second, so this will be the required. Again, let me say here, this x can be only between 0 to L and t can be greater than 0, and this is the required solution of the given initial boundary value problem. So now you have dealt with this kind of initial boundary value problems. So in the next question, we target to dealt again as homogeneous, you can say raw heat equation problem. So probably this will be the last question of today's class. So question number 5, find a temperature in homogeneous bar of heat conducting material of length L with ends kept at 0 temperature, and the initial temperature is given by alpha x L minus x divided by L square, where alpha is a constant, and in this, for this particular problem, the diffusive constant is c square. So what we have to do, first we have to form initial boundary value problem, or you can say setup for this given question, and then we have to tell what will be its temperature conductive material, ultimately what will be its solution. So first you may try at your own, then we will discuss it. So let us start. Here we have given that diffusive constant is c square. So that means your heat equation will be ut c square uxx is 0, and given length of the bar is L. So T is any positive number. Next, we have given that temperature at endpoints. So if this is your bar, so temperature at this point and temperature at this point is nothing but 0. So that means U0T is 0 is ULT, where T is greater than equal to 0. Next is initial temperature is given as, so it is the temperature and at endpoints. So initial temperature means at any x. So the temperature is given as alpha x L minus x divided by L square for any x between 0 to L. So this is your formed initial boundary value problem for this particular statement. Initial boundary value problem. So for this this is looking like a initial boundary value problem of question number 2. So again we may write its solution in the form of question number 2. What was that? Uxt is nothing but a series n1 to infinity an e to the power minus n pi alpha by L. So here alpha is c, n pi c by L whole square t, and sine n pi x by L. And from here an can be written as 2 by L integral 0 to L f x sine n pi x by L dx. If you will observe here, this fx is given as alpha x into L minus x divided by L square sine n pi x by L dx. So from here you will get, this is 2 alpha divided by L cube 0 to L Lx minus x square sine n pi x by L dx. So if we calculate this integral, it will come out to be Lx minus x square. So this will be minus cos n pi x by L divided by n pi by L. So if I would write it here like this, so this will be minus, then this will be plus L minus its derivative 2x. It was cos, so first part is 0 to L, and this will be 0 to L cos n pi x by L divided by n pi by L dx. Okay, so the next one will be, this is 2 alpha L cube. So while you will put L, this will become 0, and again while put 0, this will become 0. So plus L by, or you may write it like this only, 0 to L. So if you will integrate this one, so L minus 2x, this will give you sine n pi x by L divided by n pi by L square 0 to L with negative sign 0 to L, the derivative will be minus 2, and here it will be sine n pi x by L divided by n by L whole square dx. So the next step will be 2 alpha by L cube. So since the first one is 0, and when you will put L, this will be sin n pi. Sin n pi is 0, and again sin 0 is 0. So again that factor will also be 0. Then you will left with only this last term, which will give you the integral as with negative sign 2 cos n pi x by L n pi by L cube. So integration of sign is minus cos, so 1 minus minus will become positive, and again there is a minus sign. So 0 to L. So now this will be 4 times of alpha L cube, and from here L cube divided by n cube by cube, and while you will put L, this will be minus, or you can say cos n pi with negative sign. Cos 0 is 1. So here with negative sign is minus 1. So this will be 4 alpha divided by n cube by cube. So this will be 1 minus cos n pi, and cos n pi is minus 1 to the power n. So from here you may also expand it. If n is an even number, this minus 1 to the power n will give you 1, and this 1 minus 1 will become 0. So that means if n is an even number, this will become 0. If n is an odd number, this will give you 8 alpha divided by n cube divided by pi cube. Okay, so what will be your uxt in this case? Your uxt in this case will be summation n odd series. Only odd number series is valid, or let me write it first. General series n 1 to infinity 4 alpha n cube pi cube 1 minus minus 1 to the power n e to the power minus n pi c by L whole square t sin n pi x by L. One way to mention uxt is this. Another way of to mention uxt as n is only odd term containing odd terms, and this will become 8 alpha divided by n cube pi cube e to the power n pi c by L square t sin n pi x by L. One way to mention is this. So and the last way to mention is you may substitute this n as some odd number, and the series will be again counted from 1 to infinity. If I will substitute n is to some 2k minus 1, suppose, so put n equal to some 2k minus 1, since it is only containing odd terms. So this will give you 8 alpha divided by 2k minus 1 cube by cube e to the power minus 2k minus 1 by c divided by L, this whole square t sin 2k minus 1 by x by L. So this is your solution valid for this domain, is the required solution of the given initial boundary value problem. So one way is to mention the solution in this form. For all the three forms, our range, or you can say domain of x and t, is still the same. that x will vary from only 0 to L, and while t is vary from t is any positive real number. So this is your final um, answer. So let me just recheck this form. So this is 8 alpha pi cube L. Okay, so there is some, I think, ambiguity. Just let me check it. So 8 alpha L divided by, there should be 8 alpha L. Why so? So it was 2 by L square. We have given L square, I think. So we have given L square. So it will become L cube. Then L cube and L cube will cancel out. Just let me recheck it. So it is absolutely fine. So this was all about today's session. So let me just mention one thing from the week 10 problem solving session. So here we have concluded our eigenvalues from natural number. So our series will be expanding from natural number, but because of some ambiguity, I mention it here from 0 to infinity. This should be n from n1 to infinity. I will update this notes in the PDF form also. So although I have found out only this value of n for natural numbers only, so your series will be again 1 to infinity in all the format. Okay, in the same way, it wherever it happens in this PDF, I'll update it. So I'll update this ambiguity. So that's all from today's session. If you have any query, you may ask. Otherwise, let's conclude this session and meet into the next section of week 12. If not, thank you.